With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's begin with this question. And here in this question it says that a space chunk of mass m leave its orbit and it head towards annular disk shaped in meteor at rest relative to the earth along its axis at a distance r with a velocity v. And the surface mass density of the meteor is sigma, its inner and outer radii r and 4r, and we have to find the velocity with which chunk passes the center of the annular disk. So what is happening, we have a chunk of a space chunk. A space chunk can be created by the explosion in the space, and by that explosion a lot of mass particles are distributed in the space, and that one of that is traveling here, and it's traveling towards the center of the annular disk. Initially it is at a distance of 4r, and the disk radii are r and capital R. So we have to calculate the value of velocity at the center of the disk. Now how we solve this? First we calculate the potential at the point where the meteor is right now, and by using that we can calculate the initial and the final potential energy. And since its initial velocity is given, so we can calculate initial and final kinetic energy. After that we apply conservation of energy, and then we calculate the final velocity, which is at the center of the disk. So this is how we are going to solve this problem. So let's begin with the problem. So for solving this, first we draw the annular disk that is given in the question. It is the disk, and if we try to make the inner part, let's say this is the inner part of the disk here. Now what we do now, we will take an elemental strip here. Let's say this is let's say that this is the elemental strip that we have taken here. One more, and this, let's say this is the elemental strip that we have taken, and its width is dr, and we have taken this at a distance of r, and this is the width of this is dr. Okay, so this is the elemental strip of the disk. Now at a distance of, let's say at a distance of x, first because we are considering the general condition, so first we can say that this is at a distance of x from the center, and this particle is moving with velocity v having mass m, right? So if this distance is x, if this distance is x, then this distance from this point to here will be root of x square plus r square. So our work is to calculate the potential at this point. So dv, the potential dv will be equal to minus g into, now let's say the mass of this elemental strip is dm, so here dv is equal to minus g into dm by root of r square plus x square. Now let us calculate what is dm here. So dm will be equal to surface mass density into area, and area will be length into breadth, and length of this elemental strip is 2 pi r because it is in the shape of circle, and width will be dr. So it is sigma into 2 pi r into dr. So this is the value that we have. Now we will put the value of dm in the above equation. So dv will become from here is 2 pi sigma into g, and it is minus, it is r dr, and this is divided by root of r square plus x square. So now we are in the condition to calculate the potential. So for calculating the potential, we will integrate this equation from 0 to v, and this equation from r1 to r2. Now to calculate the integration, here we apply the integration by parts method. So for that we can assume that the lower, which is in the denominator form, r square and x square will be equal to t square, and when we differentiate we have 2t dt, and this should be equal to 2r dr, and from here t dt is equal to r dr. So what we do here, we will replace this r dr by t dt and r square plus s square by r square plus x square by t square. So by that we get the value, it is v is equal to, and it is minus 2 pi sigma into g, and in the numerator it is t dt, and in the denominator it is root of t square, and this is integrated from r1 to r2, and this gives us minus 2 pi sigma into g, and this will be dt from r1 to r2. Now when we replace dt by t, and t, when we put the value of t as r square plus x square, so v become here is v is equal to minus 2 pi sigma into g in the bracket r is in the bracket it is a small r square plus x square raised to the power 1 by 2, and its limit is from r1 to r2. So finally the value of v come out here is v is equal to minus 2 pi sigma in the bracket it is r1 in the bracket it is r2 square plus x square, so it is root of r2 square plus x square, and subtracted by it is r1 square plus x square, and this is closed bracket. So this is the value of v that we have obtained here. So the value of v is obtained here when you put the now we are interested to calculate the potential energy, that is initial potential energy will be u, and this will be equal to minus, and here there should be g also, 2, it is 2 pi sigma into g, and when you put the value of r and x, so here x is 8r and r2 is 4r, so 8r square plus 4r square, that is 64r square plus 16r square, so this will be r into root 80 minus by x is already 8r and this is r, so 8r square is 64, r square is only r, so 64r square plus r square is 65r square, and this gives us r into root 60. Okay, and if you multiply this by mass we get the potential. So this is multiplied by mass, this we get potential energy initial. Now kinetic energy initial will be equal to KEI, and it is equal to 1 by 2 mv square. Similarly, potential energy final will be equal to minus 2 pi sigma into g, and here when the particle reaches here at this point, so here x will be 0, only thing that remains is r2 square minus r1 square, so r2 is 4r square and r1 is only r square, so this become 4r minus r, that give us 3r. So here we get minus 2 pi sigma g into 3r. Now final kinetic energy, let's say it is k e final, and the velocity we take here is m v dash square. So this is the final kinetic energy. So now what we do, we apply the conservation of energy here. By using that we can calculate the velocity, final velocity of the particle. So by conservation of energy, okay, so by conservation of energy, ui plus kei, and it is equal to u final plus k e final. So this is the value. Now we put the value of ui and kei. So the value of ui is minus 2 pi sigma g into r in the bracket root 80 minus root 65, and kinetic energy is half m v square. This is also multiplied by m, and this is equal to half m v dash square minus 2 pi sigma g into r into 3 into m. So what we do now, we will cancel m from all the sides and also multiply the whole equation by 2, and we take this value towards the other side. Now the equation become, it is minus 2 pi sigma gr, and if we take, let's write it as it is, so it is root 80 minus root 65 into m, and this is this will be 4 here because we have multiplied by 2 the whole equation, so this is 4 plus 4 pi sigma g into m into 3r, and this is plus v square, and it is equal to v dash square. So what we do here, we will take common 4 pi sigma g into r, right? And here it is 3 will be here, and since it is negative, so we put negative sign here. Now it is 16 times 5 80, and this is 13 times 5, so we will take root 5 common here. It is root 5, and in the bracket it will be root 16, that will be 4 here, so we can write that here is 4, and it will be root 13, so it is root 13, and the bracket closed. This is multiplied by m, and it is plus v square is equal to v dash square. So to calculate the velocity, what we do here, we will take the root of this whole equation. So this whole equation will be divided by will be taken by root, that is power 1 by 2. So this is the value of velocity with which it crosses the center of the annular disk. So with that, we have calculated the value of with the velocity with which it crosses the center of the annular disk. So this was about this question. Thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.